All right, welcome. We are going to quickly go over basic chemistry very quickly. Life is made out of matter, and then matter is made out of smaller pieces called elements, right? And all the elements that we know of are on the periodic table. For example, this is chlorine gas, and chlorine is an element. Chlorine gas is green and it's poisonous. In this picture is sodium. Sodium is a metal. It is very soft. In this picture, they're cutting it with a knife. You can cut it with a spoon. It also explodes when it gets wet, or if the humidity is really high, it will detonate. And so you have an explosive metal and a poisonous gas, but when those two combine chemically, they lose all those properties and they form, that should be an equal sign. Let's see if we can fix that. Or not an equal sign, but an arrow. They form salt, which has completely different properties than either of the two elements. So you can have elements and they have their own properties, but when they combine chemically, they lose those properties, and then the compound will have its own set of properties. So 6 elements make up about 97% of living organisms, which means that you are about 97% these 6 elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Now, if you take an element and reduce it to its smallest part, that's going to be called an atom, right? And then hopefully you remember that atoms are made out of smaller particles. That's why they're called subatomic particles. And those are protons, neutrons, and electrons. Protons have a positive charge, like on a battery. Neutrons have no charge. Electrons have a negative charge, like the other end of a battery. Or sometimes you can think of these positive and negative charges like on a magnet. Sometimes that's helpful. Now this says all elements, but I think it means to say atoms. All atoms of the same element will have the same number of protons, but may have different numbers of neutrons, and those are called isotopes. So in this example, we have 6 protons. That means this is carbon, right? This carbon has 6 neutrons, but this one has 7. This atom has all the same properties of that one, except it's a tiny bit heavier because it has an extra neutron. This is also carbon because it has 6 protons, but it has 8 neutrons. This is another isotope of carbon, and it's a tiny bit heavier than the previous one, and it's a little heavier than the first one, but they all have the same properties. The difference is they have different number of isotopes. Now, sometimes having a different number of neutrons means that it is also radioactive. So you'd have to be cautious around those kinds of elements or those kinds of atoms. But then a lot of them just occur naturally in the ground, and they're harmless, even though they're radioactive. Radioactive means it's getting rid of some of these extra neutrons. Now, if it has a different number of electrons, that's called an ion. So different number of neutrons is an isotope. Different number of electrons is an ion. Sodium. Let me switch to black. Sodium normally has 11 electrons. And so that's like imagining 11 minus signs over here, right? And that means it has 11 protons or 11 plus signs in the middle, right? But if it loses this outermost electron, which sodium likes to do, now it only has 10 electrons, but it still has 11 protons. This is really hard to do with a mouse. And if you do the math, that's going to leave you with a +1, right? And that's what this is. They just, normally chemists will leave off the 1. If it's 2 or 3 or 4 or anything else, they'll put that on there. But if it's just 1, they just put the plus sign. And so that's why this is Na+. This is a sodium ion. Na+ means it has lost an electron, right? And so here we have a tiny bit of the periodic table, and you can see this is kind of how the electrons are laid out. In the circle closest to the nucleus of the atom, we have 1 and 2 elements, and that's the most it will hold. And then if we jump down here to lithium, well, it has 2 in the innermost circle, but then it's got a third electron out here. And so each element will keep adding electrons until you get 8 on the outside. 8, that's very important. 8 is the magic number, right? And if we skip way down here, notice on the outermost level, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 out here. That's super, super important. 8 is the magic number for most elements except hydrogen and helium, where the magic number is 2. And that'll make more sense here in a minute. So electrons move around, and you probably know this already, hopefully, in an area called the electron cloud. And they move around in these, like in the picture, they move around. In the diagrams, we like to say they're moving around in this area, and then these 8 are moving around outside those. And so they move around in these places that we call orbits or orbitals, right? And so these electrons are moving around the nucleus. Then they don't move around like the planets go around the sun. They're going crazy, but they'll be found in this area. Now, what's confusing is the naming of the orbitals, and we're pretty much going to save that for chemistry because it's not going to apply a whole lot to us in biology. But just so you know, this 1s is part of the name, 1s orbital. The number 1 has nothing to do with electrons. It has nothing to do with anything. That is just the name. Just like 2s is part of the name. 2p, is part of the name. So don't think that that just means there's 2 electrons or something like that. Just understand these are names of the locations where those electrons are found. But you'll just need to know that a little bit. So when 2 or more atoms are covalently bonded, now this is something else that hopefully you knew from last year. Covalently bonded means they share electrons. Boy, how do I do that? All right. And that's really important. Covalent bonds share electrons, and they form a molecule. So here's oxygen, or 2 oxygens, because oxygen is diatomic, which means that it normally shows up in pairs, O2. The oxygen you're breathing right now as you're watching this video comes in pairs, O2. And that's the way oxygen likes to hang out for the most part. It's pretty rare that you find one oxygen by itself. Occasionally you'll find 3 together, and that's ozone, but that's totally different stuff. Hydrogen is also diatomic. Nitrogen is also diatomic, and there's a few others that are diatomic. But anyway, covalent bonds form molecules. That's important. Water is a molecule because there are covalent bonds, shearing of electrons between hydrogen and oxygen. For example, we'll go black. Oxygen has 1, 2, 3, 4, 5, 6 electrons in its outermost layer. It wants 8 because 8 is the magic number. Hydrogen I don't know how I can do this. Hydrogen just has 1. And this hydrogen just has 1. Now remember, we said a bunch of slides ago, for hydrogen and helium, the magic number is 2. It wants to have 2 on the outside. You know, if atoms could want things, that's what they would want. They'd want 2 electrons. So what happens is these guys share these electrons. And so this electron here, this red one from the hydrogen, it's going to spend some time around hydrogen, but it's also going to spend some time around oxygen because it's shared, and that makes a covalent bond, right? Same thing is happening with these electrons here. They're being shared. So part of the time, hydrogen has 2 electrons, and that makes it happy. And then part of the time, oxygen has 8 out here, and that makes it happy, right? So covalent bonds are sharing electrons. And then out of left field, we have the periodic table of elements, which this is an old one. The atomic mass is down at the bottom, and the atomic number is at the top, and that is standard nowadays for most periodic tables, that the atomic number is going to be at the top, the atomic mass down at the bottom. But you do need to check to see if the periodic table has a legend. So how many protons and neutrons are there in an atom? So here's the atomic number. That tells us the number of protons as well as the number of electrons. And so that means that oxygen has 8 protons, and it will have, a stable atom will have 8 electrons. Now, to find neutrons is a little bit different. You have to take this number, the atomic mass, the number on the bottom, we're going to round that off, just standard rounding rules. And so that's 15.9 rounds to 16. And then we're going to subtract this number at the top, right, which is 8. So 16 minus 8 is 8. That means that oxygen has 8 neutrons. And that's how you find the neutrons for any element. And yeah, boom. The periodic table is divided into groups and periods. The groups are the vertical columns, and the periods are the rows. The vertical columns, for the most part, have similar properties, right? Which that is because they have the same number of electrons in that outermost layer. All right, this is also important. Potential energy. Potential energy is stored in covalent bonds. So potential energy is stored in that bond and in that bond right there. That's potential energy. We break that bond, you're going to release that energy. So here we have covalent bonds, which we've already said is sharing of electrons. And so covalent bonds are being shared, electrons are being shared between carbon and the hydrogens. Remember, the hydrogens, they want 2. Carbon wants 8, but carbon normally only has 4. 1, 2, 3, 4. Okay, that's close enough. And then each of those hydrogens, they just have the 1. But if they're sharing, we get 1, 2, 3, 4, 5, 6, 7, 8. That gives carbon 8. That makes it happy. Hydrogen has the 2. Each hydrogen has 2. They're all happy. Those are covalent bonds. They're sharing those electrons with each other. Ionic bonds are a little bit different. That's when electrons are given or taken. So in this case, chlorine needs 1 electron, and it will take it from sodium. It does not share it with sodium, it takes it. That leaves sodium with a positive charge because that negative has moved, and that gives the chlorine a negative charge because now we've added an extra negative over here from the moving of the electron. And then that brings us to, that's the whole essence of chemical reactions. We have, in this case, hydrogen and oxygen, and by sharing electrons, they lose their individual properties and they form water, right? These are the reactants, and then what's made at the end is called products. There you have it.